video, we are going to be exploring two examples where we have to solve equations over domains. One example is with the polynomial equation, and the other example is with the trigonometric equation. So to start off, let's start solving a polynomial equation over a particular domain. So the question we have is that a box has a width of x centimeters, and we're given a domain that the x is between 0 and 30, not including either. And the volume of the box is given by v equals 5x times 6,480 minus 5x squared all over 14. And we have to find the exact values of x for which the box's volume is exactly 13,500 cubic centimeters. So when we use our calculator, what we might do is start by going to Menu, then Algebra, and then Solve, because we're trying to solve an equation here. So we'll start by typing in the volume function, which was 5x times. So you need to make sure that you put the times there, because if you start a bracket after an x, the calculator might treat the x as a function rather than a variable, and then the equation will not solve itself. So 5x times, open a bracket, 6480 minus 5x squared, and then we can close the bracket after that, go down to the denominator, 14, press right, then the equal sign, and then the box's volume which is given to us is 13,500. After that, we need to put the variable we're solving for, so comma on the bottom left-hand side, and then x. Hit the enter command, and then you get these three values of x. The problem with that now is we have to decide which values or value of x is valid and which one we have to decline. The way to do this now is to look back at the question again and see that the domain given to us is in fact that x is between 0 and 30. So what you can do is press the up button twice to go back to the previous question. You don't need to type it all out again. Press enter so it copies it into your entry line. Then press control and the equal sign. And what happens is we get a little palette of various options. You can straight away press the left button and it comes with the vertical line. That vertical line means given. So you press given and then you give the calculator the domain, which is 0 is less than x, which is less than 30. And when you hit enter, you get a single solution of x equals 6. So that right there is the x value at which the box's volume is exactly 13,500 cubic centimeters. So now moving on to a trigonometric example where the scenario this time is the depth of water at the edge of a pier is represented by a function which is d of t is equal to 5 root 3 plus 4 sine pi t over 9, and t hours is the time passed since 12 a.m. on August 1st. Our job is to find the times at which the depth of the water is exactly 7 root 3 meters on August the 1st. So given that we've already solved an equation over here, it might be a good idea to enter the new problem. So you press the dock button, then you press insert and problem. So this starts up a new problem where all the variables, etc. are unlinked to the previous problem that we did. So I'm going to start up with the calculator page. Now before I start typing in anything, I have to make sure that I am in radians mode. This question is specifically a radian calculation, so you have to make sure that you are in radians mode. If you're not, quickly change that before starting the problem. So what I might do is first of all define the depth function. So the depth function was d of t, and one way to define it is press control and the absolute and the template button. So what that does is it gives you two dots and an equal, so that starts to define. It's the assign to command. And then you can press the function itself, 5 square root 3 plus for trig sine, start up a fraction, pi multiplied by t, tab 9, and hit enter. So that is the function. It's now defined in the calculator's memory in this particular problem. So now we can start solving our particular equation. So we can go menu, algebra, and solve. So we want to solve the command, the equation, d of t is equal to 7 square root of 3, and we're solving that equation for t. Now, if you read the question again, it says that we want to find the times at which the depth of the water is exactly 7 root 3 meters on August the 1st. So this question is specifying that we want to solve this equation specifically during the day of August 1st, which means that we want to restrict the domain, like we did in the previous example, restrict the domain to the 24 hours that August 1st spans. So I'm going to put 0 less than or equal to t, which is less than or equal to 24. And when you hit enter, you get the 4 times there. T equals 3, t equals 6, t equals 21, or t equals 24. Now, if you read the question yet again, it does say find the times at which the depth of the water is 7 root 3, and also you're told that t equals 0 is at 12 a.m. on the 1st of August. So when you write out the answer for this question, you must make sure that these times are written as clock times. So t equals 3 would be written as 3 a.m., 6 a.m., 21 would be 9 p.m., and 24 would be at midnight. So that right there are the times at which the depth of the water is exactly 7 root 3 meters on the 1st of August. But you have to be careful, because when you read a question like such as this, sometimes there could be a few tricks in there, and your conceptual understanding is pushed to the next level. And what you must make sure of here is that last time over there, which is t equals 24. If you think about that, that t equals 24 is actually 12 midnight, which starts August the 2nd. So that is actually an invalid solution. What you want to do is reject that answer and your actual answers at the end. So your final answer at the end of your solution would be 3 a.m., 6 a.m., and 9 p.m.